Find the vertex, axis of symmetry, y-intercept, direction of opening, and vertical expansion compression factor. So A, we have y equals 3 bracket x minus 5 bracket squared plus 5. The first thing is we need to recognize that this is in vertex form. So this number here gives me the x coordinate of the vertex, and this number gives me the y coordinate of the vertex. So the vertex is going to be located at 5 and 5. And just remember that if it's minus for the x, it's opposite. So minus 5 becomes positive 5. This is the expansion compression factor can be found using the A coefficient. So in this case, it is an expansion by 3 because the A value is 3. So it expands by 3. The direction of opening also comes from that A value. Since it's positive, we say it opens up. Okay, it opens in that direction. The y-intercept can always be calculated when x is equal to 0. Now, one thing that we want to make sure we don't do is, because the graphing form, we don't use that as a y-intercept. That's wrong. Okay, so we're not going to do that. We're going to make sure that we plug in x equals 0. That only works when it's in the general form. This is not general form, and it will not work for the vertex form. So I'm going to plug in x to 0 and calculate the y value. So y is equal to 3 bracket x is 0 minus 5 all squared plus 5. Then I'm going to calculate the y value. So I do the square first. So negative 5 squared is 25. And then we get 3 times 25 is 75 plus 5 is 80. So y equals 80 represents the y-intercept. And notice that is very different from the y coordinate of the vertex. Y equals 80 is my y-intercept. Now lastly, with the roots. This one here, if I actually just sketch this diagram and have an idea what it looks like, so at 5, 5, okay, and it opens in the upward direction, we're going to have the vertex at this coordinate 5, y equals 5, and opening up means that it does not cross the x-axis. So this has no real roots. Okay, so there's no roots, and we can determine that by just the shape of the graph and the where the vertex is located in relation to which direction it opens. The other thing we could actually do is we can actually solve. Roots are when y equals 0. So what I can do is make y equal to 0 and then solve for the x values when y is equal to 0. So this would be an algebraic strategy. So when I solve this equation, I'm going to, first of all, subtract 5 from both sides. So I'm going to end up with negative 5 is equal to 3 x minus 5 squared. I need to undo this to solve for x. So I'm going to divide by 3 first. And then I'm going to square root both sides of this equation to get rid of the squared. So square root. And what ends up happening is I have a square root of a negative number. That can't be done. We cannot square root negative numbers. So at this point, this cannot happen. So we have no solution for x. That means then that it does not ever get a y value of 0, which means that the graph never crosses the x-axis. Therefore, no real roots is going to be my conclusion from that. And we can get that from the actual shape of the graph. We can see that it won't cross the x-axis. That would be the easiest way to do it. If we do it algebraically, we still get the same result, but the result will be determined based on the negative inside the square root.